Hi there. In this video we're going to look at our remaining 4 circle theorems, and these ones on the right hand side, all the ones that involve tangents, and this one that doesn't involve a tangent but I think is similar enough to this one that I'm happy to put these in the same place. So again we'll go through what each of the circle theorems says and how we can apply it in context. Okay, so on to our first theorem of this video, but theorem number 6 of all of our circle theorems. A radius is perpendicular to any chord that it bisects. So if we've got a radius and I've got a chord, so a chord is any line that connects 2 points on the edge of a circle. If a radius is perpendicular to a chord, then it cuts the chord exactly in half. Similarly, if this radius cuts this chord exactly in half, you know it must be perpendicular. Okay, that's what this theorem means. So just a quick example of how to apply this theorem. So here we're told that we've got a chord here, and its radius bisects it because of these two lines. We know that this half and this half have to be the same length. So that tells me that I know one of the angles in this diagram, one that's going to be really important. Can you spot which one it is? Exactly, it's going to be this angle here, which is 90 degrees, which then means we've got enough information to work out what this angle is. So again, I know that for this 40-degree angle plus this 90-degree angle, and plus my value of x has to be equal to 180 because it's in a triangle. So then we can work out what x is without too much difficulty. 40 plus 90 is 130. So if I subtract 130 from both sides, then that gives me x is equal to 50 degrees. Okay, so our next theorem, a tangent to a point on a circle is perpendicular to the radius at that point. So basically this boils down to, if you've got a tangent to a circle, it's always perpendicular to the radius that touches the tangent. It's obviously not perpendicular to that radius, for example. It's not just any radius, and that's why we've got to specify it's the radius at that point. But if you've got a tangent and a radius that meet, then they're perpendicular. And this was quite similar to the one we just looked at. If you push the chord all the way to the edge of the circle, you can see how it sort of extrapolates to become the tangent. So just look at one example here. Again, this one is more common in the context of other questions, but as a standalone question, we'll just have a look at this one. So we've got a triangle here. Again, we know one of the angles in the triangle, and we're asked to work out this angle. Wouldn't it be nice if we knew this other angle in the triangle, then we could work it out straight away. We should be able to spot that actually we do know this third angle, and it has a value of 90 degrees. Exactly. So let's draw that on. So then I have 25 plus my 90 degrees plus my value of x. And while they're all in a triangle, they form the three angles in a triangle, so they must be equal to 180. And so we can simplify this. And 25 plus 90 is 115. So let's subtract the 115 from both sides, and we get x is equal to, well, 180, take away 115 is 65 degrees. Okay, so on to our next one. Two tangents that meet at a point are equal in length. So let's have a look here at what this means. Now we do need to be a little bit careful. The tangent technically, because it's a line and not a line segment, should go on forever. But when we're talking here, we're talking about the length of this segment between where the 2 points meet and where the tangent meets the circle. So these 2 points are the same. It kind of makes sense because if you split this circle in half, you've got this lovely line of symmetry. It does also have another sort of consequence, this theorem, as I've drawn over here, in that this angle here and this angle here have to add up to 180 degrees. And that is because we've got two right angles here angles in this quadrilateral add up to 360. So if we subtract the two 90s, that leaves us with 180. So let's have a look at some examples of this in context. Again, if you think you can have a go at these before I go through them, feel free to pause and then pick up once you've finished. Okay, so here we're asked to find this angle here, and all we're given is this angle over here, so it feels like sort of quite far away from this angle until we spot that these are two tangents, and so these two segments must be equal in length, which means we've given an isosceles triangle. And now we know that in an isosceles triangle, this angle and this angle have to be the same. So if this is the same as this, we can call this x, because we've got an isosceles triangle, which now means that these three angles have to add up to 180 degrees. I've got x plus this 30 add up to 180. Let's simplify and subtract the 30. So these two x's turn into 2x. And if I subtract that 30, that gives me 150. So now solving this divided by 2, we get that x is just equal to 75 degrees. Okay, now let's have a look at this one. So as we mentioned before, this angle and this angle need to add up to 180, because in this quadrilateral, two of the angles are 90, which together add up to 180. So let's have a quick look at this then. So if I know that 170 plus x add up to 180, then it's quite simple to spot that x is just equal to 10 degrees if we subtract the 170. There we go. Now on to our final circle theorem, the alternate segment theorem. Now this one has its own name, partly because it's quite hard to state what it means, but also because this one is quite an important circle theorem. So let's have a look at what the alternate circle theorem says. So if you see over here, I've got two pink angles and two green angles. We'll have a look up here, and I am just going to change this. Sorry, I'm just going to change this red triangle into a blue triangle, just so I'm consistent with before. There we go, and then we've got green and the pink. There we go. Sorry, I do like to be consistent. There's one thing I hate in YouTube videos, it's continuity errors. Anyway, so we've got these two angles here, and now the angle between the tangent and one leg of the triangle is always equal to the angle that's formed between the other two sides of the triangle. And that's what it means, and you can sort of picture it in that this angle is kind of pointing to the right, and this angle is kind of pointing to the right. So if they're pointing in sort of the same direction, then you know that the angles are the same. It's just sort of not a very formal way of saying it, but that's a good way to spot which are the same. So let's have a look at this example here. So let's apply the alternate segment theorem. So we've got this angle here, x. Now this angle here, x, is going to be the same as this angle here. Okay, and that's because, well, this angle is between the tangent and this side of the triangle. So if we look at the other two sides of the triangle, it's got to be the same as that. Or you can think of it as this angle sort of pointing to the right, this angle's pointing to the right again, so they have to be the same. And now that's really handy because we have this triangle, and we've done this lots today. We know how to work out the missing angle in the triangle. 70 plus 30 plus x is 180. So then x is equal to 80 degrees. If we take away the 100, we get 80 degrees. Okay, now let's have a look at this one. Now this one is a little bit trickier. So we've got a diagram here, and we've got an angle here y, an angle here x, and this angle here is 30 degrees. Okay, and we're asked to find what x plus y is. Now this is slightly different because we're not asked to find what one of these angles are, we're asked to find the sum of these angles added together, which means we might not be able to find what one of them is exactly, but we should get an answer when we both added together. So let's first of all apply our alternate segment theorem. Now there's only one angle we can apply this to, and that's this 30-degree angle here. So let's do that first of all. So this 30-degree angle here, and it's between these two sides of my triangle. So I know that this angle here must also be 30 degrees between the tangent and the other side of that triangle. Okay, so let's have a look here then. Now I know that this angle and this angle are related. Okay, and I know that both of those added together must be 180 degrees. Now I don't know what they are, so what I'm going to do is I'm going to give it a name. Quite often in maths it's handy to give things we don't know names, and I'm going to call this angle on top A, which means to work out this other angle, if I knew that was a number, I'd subtract it from 180. I can do the same thing. If that one on the top is A, then this one on the bottom is 180 minus A. And this allows us now to start setting up some equations. So let's look at the triangle inside the circle. I know that this angle here is x, this angle here is 30, and this angle here is A. So I know that x plus 30 plus A has to be equal to 180. And we can do a similar trick with this triangle down here. So I know y plus 30 plus 180 minus A. Again, so this green angle here is 180 take away A, it's not just A anymore. So 180 minus A. I know that that has to be equal to 182. Now, what we can do now is we make x the subject of this top equation and y the subject of this bottom equation, and that'll give us a nice route we can take. So looking at this top equation, if I subtract 30 from both sides, I get 150. Let's do that now. 150. And then if I subtract A from both sides, well, it turns into 150 minus A. So that top equation turns into x is 150 take away A. I'm doing a similar trick with this bottom equation. If I subtract 180 from both sides, well, it gets rid of that 180 and gets rid of that 180. Then subtract the 30, I get negative 30. And this time I need to add the A to get rid of the negative A. It gives me minus 30 plus A. Okay, beautiful. We're nearly there now. So if x is 150 minus A and y is negative 30 plus A, if I add those together, then I get 150 minus A minus 30, or plus minus 30 plus A. Now I don't need to write plus minus 30, so I'm just going to write minus 30 plus my A. And now look what happens. My minus A and my plus A are going to cancel. And I'm just left with 150 take away 30, which gives me a value of 120. So I know that x plus y is equal to 120 degrees. Okay. So on a single circle theorem, that's probably the hardest sort of thing you're going to get asked. In the next video, we're going to look at how we can combine circle theorems to solve much larger problems. And then after that, in the following video, we'll look at how we prove these circle theorems, because that is something you need to be able to do for GCSE.